Today I'm going to be tearing apart a solid-state relay. Now, they come in a few different flavors. Some solid-state relays only work with DC loads, and others are meant to switch on and off AC loads. This one was a DC solid-state relay, and it died on me. It let out the magic smoke, so we're going to tear it open and see what's inside. So the first step is to remove the heatsink back plate. And the best way that I found to do this is to put it in a vise so that only the plastic is being held, and then with a pair of pliers, grab onto the metal tab and bend downward until the heatsink is removed. You can see some of the glue that was used to hold it in place to the metal or to the plastic box, and also a little bit of thermal paste and this thermal pad that electrically isolates, or it doesn't conduct electricity, but it does conduct heat from the back of this transistor package to this to the heatsink plate. So this is the main switching device. It's probably a MOSFET. Let's look at the rated voltage on the output, 220. Well, it may be an IGBT. There's a couple different types of transistors that are used to switch on and off high power loads, and MOSFETs or let's see, there's a metal oxide transistor. It's a voltage controlled device, and a IGBT is a insulated gate bipolar junction transistor. Now with all of this black resin, I can't see the components from this side at least, so I'm going to remove the top plate. And to do that, first make sure I had to take out all of these little screw terminals because they were actually holding on the top plate. So we're using like a screwdriver or maybe a blade, you can pry the top off and just work your way around the outside, right? And that'll come off, reveal a little bit more. There's more black resin covering the electronics. It's probably not to keep anything a secret from people who want to crack it open, more to keep it safe and keep corrosion, from being able to happen, basically by making sure that there are no exposed copper or solder joints to the air, so it just reduces corrosion. There's actually nothing holding the circuit board in at this point except maybe a little bit of this black resin leaking over the edges, so just carefully work out around each corner, pushing upward, and it should come out the top. So there's one corner kind of lifting up. Okay, I'm curious, maybe I can save this package and use it for something else. I like the ruggedness of it and the screw terminals and all that. Anyway, this is the complete circuit. Of course, this is the indicator LED that turns on whenever you apply 3 volts or more to the input. You can see the leads of this transistor package coming up through the circuit board. They kind of connect onto the top. Kind of interesting that the way that they did that. Oftentimes the transistor, when it's laying flat, will just be soldered directly onto the circuit board, but they have it raised up, perhaps for better thermal properties. They didn't want the circuit board heating up too much in case the transistor got hot. I also see what appears to be a very small transformer or a coil of some kind that's probably used for isolating the input to the output. Oftentimes there will be a optocoupler isolator inside one of these, and basically an optocoupler is a light that shines into a light sensor, but the whole thing is covered in black epoxy. And and it seems a little pointless, right, to have a light that is completely inside of a piece of plastic, but it's meant to be a type of a switch that has no wires connecting the input stage to the output stage. So whenever the light turns on, the sensor detects that the light is turned on, and then the output also turns on. So, but there's no physical contact. It's done via light in a black box. I don't see that on here. I think they're doing it with a transformer, which is a little different. It uses, again, there's no electrical wires running from the primary side of the transformer to the secondary. Instead, is magnetic lines of flux or magnetic field transfers energy through the iron core. So a little bit different principle, but you'll notice there aren't any complex integrated circuits on this, at least not that I can see. The most complicated devices on here are probably the transistor and the transformer. I'm always curious to see what kinds of things that they put in electronics, especially trying to achieve, low prices and high volume. Got to make decisions, so it's fun to see what the manufacturers ended up doing to make the product. And I hope you enjoyed seeing this teardown video. Thank you for watching.